So the next part of this playlist is actually looking at machines. And what machines are, they're actually multiple parts being composed into one system. So, for example, we're gonna look at this eyelet squeezer. We're gonna actually do an example on this eyelet squeezer. So it'll be something like this. It'll be like a wrench or something of that sort, and it'll look something like this. And this is gonna be the thing we're trying to squeeze. And then this is the other component, which is free to slide about that point. And then this is going to be some sort of handle. So we're going to have something that looks like this. And then what we're going to have here is some two force member that is being attached right here to this handle. So this is an example of a machine, and the main purpose of this machine is to squeeze this eyelet. So let's say we're a hand is squeezing vertically downward here, and vertically downward here, and we could define these points as A, B, and C, and then we'll keep that as the eyelet. So what we're going to do is actually explode this machine into various parts and apply free body diagrams on each part. So what we're going to do is actually explode this diagram. So it's actually not that difficult. So we could say this. So we exploded this machine into various parts, and now we're going to apply Newton's third law and draw the free body diagram. So what's given here, we draw the force P, and we draw the force P here. And we know that this is actually a two force member, and for this to be in equilibrium, we have to draw forces that are in the same or in opposite directions but same in magnitude. So what we're going to do for that is going to be like that. So there's reaction forces for this two force member that lie here, and it doesn't cause any moment about this bar or this two force member. So by Newton's third law, where this point lines up on this free body diagram, we could draw the reaction force in that direction, and then similarly here we could draw it here on this free body diagram. And then this is going to be a pin, so that allows rotation. So what I'm going to do here is draw AY, the reaction force, in that direction, and AX in that direction. So we also have to apply the same idea of Newton's third law onto this bar, is actually pointing in that direction and that direction, because Newton's third law says every force has an opposite force and equal in magnitude. So the idea of a reaction force. And then there's going to be a normal force in this direction, which is going to be opposite magnitude in that direction. And then there's going to be a normal force here, and there's going to be a normal force here. And then what else applies? So, and then there's a contact force right here, which is a smooth contact force. So this is going to be something that looks like this, and something that looks like this. So what we did, we exploded this machine into various parts and applied Newton's third law and drew the forces that are acting on each part and treated each part as its own free body diagram. And I drew these force vectors in arbitrary directions. So it doesn't matter which way you draw AY or AX, for example, as long as you're consistent with your Cartesian coordinate system and what you drew as the vectors, or what you drew for the vectors, what directions you drew for the vectors. As long as you're consistent with those two things, and you do the math correctly, you should still get the same answer. You just gotta redefine your vectors, because some values may be negative, or when solving this for solving various problems. So again, you just explode this part into various components and just apply the idea of reaction forces onto each diagram and Newton's third law between diagrams. So for this point A and this point A. So that is just the very basic concept of what machines are. They're just composed of various parts, and it allows you to explode this part. Oh, one more important thing is that if you add up these free body diagrams together and reconnected these parts into one big machine, what you should get is actually this diagram, this idea of a free body diagram, meaning that there's only two forces being applied. These two forces right here, P and P. So if you add up all these vectors, so for example, AX plus this AX would actually cancel, and this AY and this AY will actually cancel. So when you do that to all these other reaction forces, what you'll get is these two remaining forces, P, being applied at the handles, and it should look something like this. And that's just a way to recognize that you did this correctly, or you exploded this machine correctly.